Hey guys, we are in chapter 7. We are talking about percents. Our learning objectives for this video will be to convert between percent, decimals, and fractions, solve problems involving percents, find percent increase or decrease, and to evaluate the validity of claims based on percents. I like this chapter or this section because it really does pertain to our everyday lives. We deal with percents every day, whether we know it or not, especially when we're shopping. So we'll see a couple of examples like that. So let's go ahead and get started. Have you ever been shopping, come across a clearance rack that says something like 40% off the lowest ticketed price, and you had to ask someone what the discounted price of a certain item would be? Okay, you're not alone. Any math teacher will tell you that people ask us questions like that all the time. They always want me to do the tip or to figure out, the discount, the sale price. But anybody can do this, okay? So to work with percents and calculations, we need to convert them to either decimals or fractions. So to change a percent to a decimal, we're going to drop the percent sign and move the decimal 2 points to the left, okay? So to go from percent to decimal, we're going to drop the percent sign and move the decimal 2 spots to the left. And then to convert a percent to a fraction, we're going to write a fraction with the percent in the numerator and 100 in the denominator, okay? And the reason why we do that is because percent means per 100, okay? I teach my students the percent sign looks like a 1 and a 0 and a 0. So percent means per 100. Therefore, when we go to write the fractions, we can just put it over 100. All right, let's go ahead and hop into some examples. We're going to convert. Oh, sorry, guys. Dropped my pen. We are going to convert these percents into decimals and into fractions. So let's just go ahead and write 80% as a decimal. We drop the percent sign. Remember, there's technically a decimal here. We want to move that decimal 2 spots to the left. So we get 0.8 as our decimal. And then as a fraction, we can put that 8 over 100. As always, we should reduce, okay? We can reduce by 80%. I'm like, something's not right. 80% out of 100, we can reduce by 20 and get 4/5. You could have also changed it from the decimal 0.8, which is 8/10, and reduced it by 2 and got 4/5. Either way works. Okay, then we have 37.5%, and we want to write that as a decimal. We drop the percent sign, move the decimal 2 spots to the left. That's decimal 0.375. Okay, and then to write that as a fraction, we can write 37.5 over 100 and then reduce it. Or we can write 375 thousandths, because once again, that's place value, and then that actually reduces down to 3/8. Last but not least, we have 6%. Once again, you drop that percent sign and you just have 6.0. Move it back 2 times. Our decimal is decimal 0.06. As a fraction, 6% is 600ths. Either way it goes, whether we're using the percent or the decimal. And then we can reduce that by 2 and get 3/50. All right. All right, now we're going to talk about going to percent. So to convert a decimal to a percent, we are going to move the decimal 2 spots to the right and then put the percent sign back on. So we're doing the opposite. To go from percent to decimal, we have to move it to the left. Now to go from a decimal to a percent, we're going to move it to the right and then put the percent sign back on. And then to change a fraction to a percent, we're going to change the fraction to a decimal first by dividing, then changing the decimal to a percent by multiplying by 100. Okay, so let's try it out. Convert each to a percent. Well, we just need to multiply by 100 in this place, or move the decimal 2 times to the right, and that's the same thing as here, 2 times. Okay, and we end up with 47.2, and then put that percent sign back on. This says 1.03 or 1 and 300ths. This is telling me, because this is a 1, I'm going to have more than 100%. So I'm going to multiply by 100, and I'm going to get 103%. 7/8 is a fraction. I need to first turn it into a decimal by dividing. This division bar or this fraction bar means divide. 7 divided by 8 gives me 0.875. Multiply by 100, and I get 87.5%. And then we have 5/6. Once again, I'm going to divide to turn it into a decimal, and I get I get 8.83.3, and that's a repeating decimal. Sorry, when I divide it, that's actually my percent. I'm jumping ahead of myself, guys. Sorry. When I divide it, 5, write it out. Okay. Yeah, that's what it is. Sorry. Repeating 3, multiply by 100, I get 83.3%. Okay. And then you always want to kind of look at your percents and say, do these numbers make sense? Well, 5/6, 6/6 is a whole, which will be 100%. So yes, it's about 80%. Same thing, 7/8 is close to 8/8, which is a whole. So that should be in the 80s too. Okay, so always just kind of check and make sure your percentages make sense. The most common calculations involving percents involve finding a percentage of some quantity. To understand how to do so, consider the following example. You probably know that 50% of 10 is 5. Let's rewrite the statement, then turn it into a calculation. Well, 50% of 10 is 5. 50% we can turn into a decimal by moving that decimal back 2 times, 1, 2. Of always means times in math, or multiply. And then it says 10 is always the equal sign, and then we have 5. So when writing a percentage statement in symbols, the word of becomes multiplication, as we just said, and the word is becomes the equal sign. And then you also saw that we changed the percent to a decimal. And now we're going to practice some examples of doing so. So according to Fast Staff Travel Nursing, about 9.1% of all registered nurses in the United States are men. Okay. The average hospital in 2016 had 347 registered nurses. How many will likely be males? Well, it's telling us here that 9.1% of all registered nurses, well, here they're telling us that we had 347 registered nurses are male. So we're going to find 9.1% of 347. We could change this to a decimal by moving that back. Remember that open spot, a 0 can fill that in, times 347 equals about 31.6, okay? Well, we're talking about humans. We're talking about male nurses, so we don't want the 0.6. We can round that to about 32 male nurses. All right, example 4. My wife is an absolute wizard with Macy's coupons. As a high-volume shopper, she gets quite a few coupons in the mail. Some of us women can agree with that, okay? We get all these coupons. Once you start shopping somewhere or anywhere, not just Macy's, they start sending you coupons so that you can spend more money with them. So on one recent mall outing, she found a lovely red strapless number with a selling price of $79. So she found a dress for $79. She had 2 coupons. She had one that says $15 off any purchase of $50 or more, and she had one that just said 20% off any item. We need to figure out which one is the better choice, okay? So the dress is $79. Let's test them both out. If it's $79, then we can use the $15 off. So 79 minus 15 gives us $64. So if she uses the first coupon, she's going to pay $64. The next coupon says 20% off of any item. So 20% of the $79 will be the discount. Okay, that will be the discount. So if you work that out, that's $15.80 as the discount. Okay, that discount is more than that $15 coupon. It's 80 cents more. So which is the better choice? The 20% off coupon. Okay, how much will the dress cost with that coupon? Well, we just take the $79 and subtract the $15.80. You guys have your calculators. You can do it in your calculators. And we get $63.23, not 23 cents, $63.20. That's how much the dress will cost with the 20% off coupon in comparison to the $64. The sales tax in our county is 6.5%. What is the total cost including tax? Well, now you have to figure out what 6.5% of the new cost of the dress, $63.20 would be. Okay. All right, so you should get a sales tax of $4.11 as the tax. Total cost would be plus the $63.20, which should give you $67.31. All right, remember it is a video, so if you need a moment, go ahead and pause it and make sure you're understanding what we're doing. Otherwise, I'm just going to keep going. Okay, a medium-sized company reported that it had to cut its workforce back to 70% of what it was last year. 70% of what it was last year. If it has 63 workers now, how many did it have a year ago? So that's our X. What we're looking for is going to be our variable, okay? So we're looking for 70% of X, and that should equal what we have now. So I can change this to 0.7x equals 63. Now it's in a linear equation, which we know how to solve. Divide both sides by decimal point 7/7, and we get x equals 90. So this is telling me that last year there were 90 workers. When they cut it back 70%, so they took 70% of the 90, we end up with 63 workers this year. Excuse me. All right, example 6. The real estate agent receives a 7% commission on all homes. Commission, okay? Commission is pretty much extra money. So if you work for a car dealership and you sell a car, you get commission on that car. You get, in addition to whatever your hourly wage may be, you earn a commission. If you sell cell phones, you get a commission, which is why every time you walk into AT&T, or PTCI or whatever phone company you work with, you deal with, they want to sell you the most expensive phone because those people are earning commission on those phones. But real estate is a big one. You earn commission on the homes you sell. Some real estate agents only earn that commission, while others also earn money from working for the company and things like that. But pretty much commission is just saying, okay, this is a piece. This is a percent. Commission is a percentage of a sale. So a real estate agent receives a 7% commission on all home sales. How expensive was a home if she received a commission of $5,775? Okay, well, she receives 7% of the cost of a home. We don't know the cost of the home, but we know that 7% of that cost of the home is $57.75. So to change this to a decimal, I'm going to bring that back twice. 0.07x equals $57.75. Once you divide those two, you end up with X, the cost of the home, $82,500. All right, next up, we have percent increase and percent decrease. Sometimes it's useful to find a percent increase or decrease in a specific situation, okay? In this case, we will use this method. We're going to turn them into fractions. We're going to take the amount of the increase or the amount of decrease, in other words, the difference, totally spelled that wrong, and divide it by the original amount. So a government promises voters that there will be 15% cut in spending for the new fiscal year. The city's budget was $72.5 million this past year and is projected to be $64.3 million for the next year. Is the government keeping its promise? Okay, well, let's figure out the percent increase or decrease. It was $72.5 million this past year, and in the future is projected to be $64.3. So we're going to subtract those. We get 8.2. So the difference is 8.2. We're going to divide it by the original amount. If it was 72.5, that's the original amount. Okay, and we get... And we want to turn that to a percent by multiplying by 100. So we get about 11%. So is the government keeping its promise? Well, they promised the voters 15%, and they are at about 11.3%. So no, they are not keeping their promise. Okay. It is key and very important that you are dividing by the original amount. So make sure you're reading the question and figuring out what's the original amount. Percent increase or decrease is often misused, sometimes intentionally, sometimes not. In example 8, we'll look at a common deceptive use of percents in advertising. Okay, a department store advertised that certain merchandise was reduced 25%. Also, an additional 10% discount card will be given to the first 200 people who entered the store on a specific date. The advertisement then stated that this amounted to 35% reduction in the price of an item. Is the advertiser being honest? Okay, so let's read this one more time. Department store advertised that certain merchandise was reduced 25%. And then an additional 10% discount card will be given to the first 200 people. It also stated that this was the same thing as 35%. So they're saying that 25% off plus an additional 10% off of the already reduced merchandise was the same thing as just getting 35% off. Let's see if they're being honest. Well, let's just act like we were buying the item for $50. Okay, we can figure out 25% of the $50 was $12.50. Okay, which means that our new reduced price will be that $50 minus $12.50, giving us the $37.50. Okay, that was the original 25% off. Then it says plus this 10%, right? So now we need 10% of this cost, which is what we see here, which is $3.75. So now we take our 25% off and subtract our 10% off to give us a cost of $33.75. Okay, the final amount is 50 minus $33.75, which is $16.25 less than the original price. Now let's find the percent of the total reduction. Okay, the total percent of reduction was 32.5%, not 35% as advertised. So if you take the difference, okay, the $16.25 and divide it by the original price, okay, we get the percent decrease. Well, they said that this percent decrease was the same as this percent decrease. They were telling a tale. Lies. All lies. Okay? Make sure that you are using your coupons wisely. That's what this lesson was about. Do not allow the stores to trick you. Okay. All right, that is actually the end of this section. Make sure you are reading your discussions, okay, and preparing to answer those during our discussion post. Okay, write down any questions, comments, or concerns that you have for me, and make